Hi everyone, in today's lesson for notes number 1 from Unit 5, we'll be taking a look at writing ratios and solving proportions. A ratio is a comparison between two things or two quantities. Ratios can be written in 3 different ways. You can write it as A to B with the word to in between the two things you're comparing. You can write it as A to B side by side with a colon in between. Most often, though, we're going to be taking a look at ratios written as fractions. So all 3 of these things mean the comparison of quantity A to quantity B. A proportion is an equation that shows 2 equal ratios. So we set 2 fractions equal to each other. When we solve proportions, we use something called a cross product. So you may have heard it referred to as cross multiplying, but what we do is we want to take and multiply n times 26, and we'll set it equal to what we get along the other diagonal. So I'm going to write it as 26 times n, because that's the way we're used to seeing it written when we're multiplying a number times a variable. And then that's going to be equal to the product of 13 times 4. Right, so we have 26n is equal to 13 times 4, and 13 times 4 is 52. Then take and divide both sides by 26 to get that final answer, n is equal to 2. Right, so we're going to spend most of our time today just taking a look at how we solve proportions. So we want to multiply along the diagonal, and number 1, we're going to take 5 and multiply it by x. And we're going to set that equal to what we get with 3 times 15. So we'll have 5 times x equals 3 times 15, or 5x is equal to 45. And then divide both sides by 5. 5 divided by 5 is 1, so we have x is equal to 45 divided by 5, which is 9. And you can always check your answer by plugging it back into the original problem. Right, one thing about number 2 before we get started, if you see any addition or subtraction in any numerator or denominator, I want you to put it in parentheses automatically. See, if you saw, I just went through all the problems in 2, 3, and 4 and put all the addition and subtraction in parentheses. That's because when we cross multiply, we're going to have to use the distributive property. Okay, so we're going to, in number 2, we'll take 6 times x, and we're going to set it equal to the product of 4 and the quantity of 20 minus x. So 6 times x from our first diagonal, set it equal to 4 times the quantity of 20 minus x. Now, one common mistake is that people want to write a fraction when they do this, like 6x over 4 times 20 minus x. Well, that would be really confusing. That's not something that you can solve. So remember, when you do a cross product, you're going to set the two products equal to each other. So you've got 6x is equal to, and on the right-hand side, take and distribute that 4. 4 times 20 is 80. 4 times that negative x is negative 4x. Get all the x's to the same side by adding 4x to both sides. 6x plus 4x is 10x, and that's equal to 80. And then we need to take and divide both sides by 10. And 80 divided by 10 is going to give us x is equal to 8. Now we've had 2 problems and 2 answers that were positive whole numbers. And I just have to give you a heads up that your answers might be decimals, they could be fractions, they could be positive, they can be negative. And the only way to tell if they're correct or not is to take your answers and plug them into the original equation to see if they make it a true statement. All right, so let's check out number 3. So we're going to cross multiply. We'll take 5 times x minus 1. And we'll set it equal to what we get along the other diagonal. And that will be the product of 2 times x plus 1. Okay, so 5 times x minus 1 equals 2 times x plus 1. Distribute the 5, and we get 5x minus 5. Distribute the 2, and we get 2x plus 2. Okay, take and subtract 2x from both sides. So it's all algebra in here. 5x minus 2x is 3x minus 5 equals 2. Take and add 5 to both sides. 2 plus 5 is 7. And so notice we have 3x left on the left-hand side of our equation. There's our equal sign. And we have 7 on the right. And sometimes students stop here and you think that you're wrong, but this is actually going to give us the right answer when we divide by 3. We get x is equal to 7/3. Final answer. All right, and number 4, when we cross multiply, we're going to see something a little different here. So this one, we're going to have to use our rules for exponents. So that might be a little bit of a review, a little bit of a stretch. Okay, it's been a while since you've done Algebra 1 completely. Okay, so along one diagonal we have the product of x minus 3 and x plus 4. And along the other diagonal we have the product of x times x. Let's do that part first. X times x will give us x squared because when you multiply like bases you add the exponents. On the left-hand side, we have to multiply or distribute in here. Sometimes people refer to it as the FOIL method for multiplication. You have to make sure everything in the first set of parentheses gets multiplied by everything in the second set of parentheses. So the first terms I would do are x times x, which gives me x squared. Then take that x times the 4, and that would be positive 4x. Now go to the negative 3, and negative 3 times x is negative 3x, and negative 3 times 4 is negative 12. Okay, now in algebra you always try to get your like terms together, and when I try to move the x squared to the other side by subtracting it from both sides, what happens is that they subtract to 0. So we don't have any x squareds anymore. Okay. In here, combine your like terms. 4x minus 3x is 1x, or just x, minus 12, and it's equal to 0 now. Take and add 12 to both sides of your equation, and we end up with x is equal to 12. Final answer. So we had a quadratic in there. We had x squared in there, but the x squared subtracted out, so we ended up just with x equals 12. Okay, so first thing I'm going to do on 5 through 8 is take and put parentheses around all of those terms where I see addition or subtraction. Okay, so again, we're going to cross multiply. If you'd like, pause the video and try these on your own and come back and check your answers. Although number 5, you might want to stay here for. This one is a tricky one. Okay. So when I cross multiply, I'm going to take the x times x plus 1 along my green diagonal there and set it equal to 6 times x minus 1. X times x gives me x squared. X times 1 gives me 1x, or just x. 6 times x on the right-hand side gives us 6x, and 6 times negative 1 is negative 6. All right, on the last problem, we saw x squared in there, but they subtracted to 0. In this case, they don't. So we only have 1x squared. So instead, we're going to take and move the 6x and the minus 6 to the other side of the equation. All right, so what I want to do is take and subtract 6x from both sides. And that's going to give us x squared minus 5x, because 1x minus 6x is negative 5x, equals negative 6. And then I have to add that 6 to the other side. So it becomes x squared minus 5x plus 6 equals 0. All right, this is what makes this tricky. So depending on what you covered in Algebra 1, and I know last year was kind of a funky year as far as learning goes. So you may not remember how to solve this quadratic equation by factoring. Factoring means we're going to try to break it down into the two sets of parentheses that would multiply back together to give us this. So x squared would come from taking x times x. Remember that when we multiply two sets of parentheses, we multiply those first terms together. So x times x would give us an x squared. The next clue that we have is that the middle term is negative, last term is positive. That always means you're going to have two negatives in your parenthesis. Because we have to think of factors of 6, that last number, that are going to add or subtract to give us -5, and factors of 6 would either be 1 and 6 or 2 and 3. And I know if I put -2 and -3 in there, a -2 times -3 would get us back to +6, but -3x on the outside and -2x on the inside would add to my -5x. Okay, so when you are factoring, you always want to check by multiplying your two sets of parentheses back together. All right, next, because the product of this x minus 2 and this x minus 3 is equal to 0, either x minus 2 has to equal 0 or x minus 3 has to equal 0. So we end up with x equals 2 once I add 2 to both sides, and x equals 3. So as I mentioned, this is a special problem. That's why I put a star next to it, because there are actually two solutions. All right, and number 6, we're back to an easier one. We're going to take a multiply along that diagonal. We'll have 6x, and then we'll set it equal to 1 times x plus 9. So 6 times x equals 1 times x plus 9. Well, multiplying by 1 isn't going to change anything, so just have 6x equals x plus 9. Take and subtract x from both sides, and we end up with 5x is equal to 9, and then we need to take and divide by 5. So we get x equals 9/5. So again, you can just leave it as 9/5. You could write it as a decimal, which will be 1.8. And that might be easier to plug in to check your work. Again, don't automatically assume that you're wrong. If you end up with a fraction or a decimal, take your answer and plug it into the original equation for x to see if you're right. And again, this one, you might want to convert it to a decimal before you plug it in. Okay, so number 7, we're going to take 2 times x plus 8, and we'll set it equal to 3 times x. So 2 times x plus 8 equals 3x. Distribute that 2 to everything inside the parentheses. 2 times x is 2x, 2 times 8 is 16, and that's equal to 3x. Take and subtract 2x from both sides. We end up with 1x on the right-hand side of our equal sign, but we have 16 over here, so it's 16 is equal to 1x, or just 16 equals x. Final answer. All right, one last one of this type. We're going to multiply along those diagonals again. So take 12 times the x plus 2 and set it equal to 4 times 2x plus 5. So 12 times x plus 2 equals 4 times 2x plus 5. So 12 times x is 12x. 12 times 2 is 24. Over here, 4 times 2x is 8x, and 4 times 5 is 20. All right, let's get the x's together on the left-hand side. Subtract 8x from both sides. So that's going to go to 0 on the right-hand side of our equation. 12x minus 8x is 4x on the left-hand side. So you have 4x plus 24 equals 20. We need to subtract 24 from both sides. And 20 minus 24 does give us negative 4. So what we have left over is 4x on the left-hand side of our equal sign. So 4x equals negative 4. So I'm going to rewrite that over here. 4x equals negative 4. And then take and divide by 4. And we end up with x equals negative 1. Final answer. Okay, for our last section here, we have some word problems. And it says, use a proportion to solve each problem. So it says the ratio of seniors to juniors in the math club is 2 to 3. If there are 21 juniors, how many seniors are in the club? So one way to go about doing this is to compare the number of seniors to the number of juniors. So we want to compare them in this order. You see that? It says seniors to juniors. So I'm going to write a little fraction here. Seniors to juniors. All right, so the ratio of seniors to juniors is 2 to 3. That's given right here. Remember that ratios can be written a lot of different ways. Here it's written with a colon, but we can convert that to a fraction. Because if we can convert it to a fraction, then we can start to set up a proportion. So we want to compare seniors to juniors. All right, the next line says that there are 21 juniors. So it says how many seniors are there when there are 21 juniors. So 2 to 3 is going to be equal to x over 21. Again, it says how many seniors are in the club, and I'm letting that be equal to x. And at the same time, we have 21 juniors. Right, we've got a proportion, and remember that we're going to multiply along those two diagonals to solve it. So we end up with 3 times x is equal to 2 times 21, or 3x equals 42, and take and divide by 3. And we end up with x is equal to 14, and we're going to put on there that this is 14 seniors. All right, number 12, we're comparing the height of a building to its shadow. It says a 15-foot building, that's the height of that building, casts a 9-foot shadow. All right, it says how tall, there's our x, is a building that casts a 30-foot shadow at the same time. So we just want to be consistent in setting up our ratios. We want to compare the height to the length of the shadow. So as long as you write your two fractions in the same way, you'll be fine. So either do height over shadow or shadow over height. I'm doing height over shadow because that's the order in which they appear in the problem. So again, it has a 15-foot height, so I'm going to put 15 in my numerator. And the length of the shadow is 9 feet. So I'm going to put that in the denominator. So 15 over 9, and we're going to set it equal to. Now, the other building has a height that we don't know. That's where the x goes. But we do know that its shadow is 30 feet long. So we're going to put 30 in that denominator. So 15 over 9 equals x over 30. All right, I think you know what comes next. We're going to cross multiply, so take 9 times x and set it equal to 15 times 30. So 9x equals 15 times 30. 15 times 30, pretty big number, it's 450. And then we need to take and divide both sides by 9. So that'll give us x alone. And 450 divided by 9, it's pretty easy math. It's going to give us 50 feet. And again, I'm putting a unit on there because it's a height. It's an application problem, so we should put units in there. All right, last one. It says in number 13, a photo that is 3 inches wide and 5 inches high was enlarged so that it is 12 inches wide how high is the enlargement. So that's going to be our x. All right, so notice I'm using color there to kind of help us set up our relationship. We want to compare the width to the height. So just be consistent, all right? So if you're doing width to height, you want to compare 3 inches wide to 5 inches high, because those two go together for the original. So width over height. And on the enlargement, it's 12 inches wide, but we don't know the height. And you can use an h for height if you wish, but just sticking with x, it's a little bit easy. All right, cross multiply, and we're going to take that 3 times x, and we're going to set it equal to 12 times 5. So when we do that, we get 3x is equal to 5 times 12, or 3x is equal to 60, and then take and divide by 3. And we end up with x is equal to 20 inches. So it's a pretty big enlargement if it's 12 inches by 20 inches, something for your wall. All right, good luck on the practice. Look for instructions on which problems to do in Google Classroom. And of course, if you need help with this, get in touch with me by email or see me in person.